In the last math video, we talked about solving oblique and right triangles. We worked an example of each. With the right triangle, we're just using the basic definitions of sine, cosine, or tangent, depending on what you're given. If it's an oblique triangle, that is, it doesn't have a right angle, you could have an obtuse angle, you could have all acute angles. In that case, you'd have to use law of sines. Here's the formula, or formulas. And I talked about how to use these. So if you didn't see the video, I'll put a link in the description just in case you want to refer to that. Formulas for the law of cosines. And most of these are pretty straightforward. Just plug it into your formula. These are the four cases you have. For the first two, you use the law of sines. For the last two, cases 3 and 4, you use the law of cosines. But again, I won't go into much detail because I did that in the video. So again, the link will be in the description. I want to focus today on the case 2, which is called the ambiguous case. You're given two sides and the angle opposite one of them, one of the sides, side angle. And this is the scenario where you could have either one triangle possible, two triangles, or no triangle possible. That is no solution. It's going to depend on one of the sides. So the angle given, say, will be angle A. And this would be side A, lowercase here. This would be, say, angle B. And this opposite side over here would be side lowercase b. This would be angle C, capital letter, and then the side opposite that would be C. So whether you have one triangle, two triangles, or no triangle will depend on the relative relationship in terms of length between A, this perpendicular here, whether A is greater than or equal to B or less than B, and so forth. So if A is equal to the altitude, you're going to have one triangle. If A is greater than or equal to B, it's going to come over here. But if A is less than B, but greater than H, you could have this scenario where we have this triangle over here, an obtuse triangle, or you could have this triangle here, acute angle. Obviously, if A is less than this altitude here, you can't form a triangle. So that's the case where you have no solution or no triangle possible. But again, I'm going to explain the scenario when I work the problems here. So again, the link will be in the description. So let's just go to the first one that I'm going to look at. So angle A is given to be 50. Label it here. This is 50 degrees. And side A is over here. And that's given to be 3. Label this as angle B. And side B is given to be 2. Given to be 2. This then will be angle C. Angle C. And then the side opposite is lowercase c. So we need to solve the triangle, then we need the missing parts. So obviously we need angle C over here. We need side C. Okay, it's over here then. And of course we need angle B. So here's where you use the trig functions. So obviously I'm going to find angle B first. So I'm going to say, using the law of sines formulas, I can take the sine of angle B over the length of the opposite side. Obviously it has to be given, otherwise I can't use this setup. Here it is. And then I know A to be 50, so obviously I want to use that. Sine of 50. The opposite side is 3. So it's always the sine of the angle over the length of the opposite side, equal to the sine of another angle over the length of the opposite side. Okay, or you could have the sides on top in the numerator and the sine of the angle in the denominator, as long as you're consistent on both sides. So then I'm going to solve for angle B. So I'm going to first multiply both sides by 2. And now you could do this calculation here. You could do this calculation here. Divide by 3, round it off, and then use your calculator, use the sine inverse. Now I want to point this out to you. At this point here, if you were to calculate this in your calculator, and you get a number larger than 1, remember the domain of the sine function is between -1 and 1. So if you get something outside that range, it's not defined. That's the case where there's no solution. So you can do this first to guarantee yourself that there is no solution if it's larger than 1. But from what we talked about in the last video that I mentioned, if side A, that is the side opposite the given angle, in this case 50 degrees, this side 3 is larger than 2, if A is greater than or equal to 2, or to B, in this case A is 3 and B is 2, you could have one triangle possible. So what I'll do here is B will equal 2. I take the sine inverse of both sides here. So B will equal the sine inverse. B will be sine inverse of 2 sine of 50 degrees over 3. Now make sure your calculator is in degree mode. I'll take the calculator over here and turn it on here. So I want sine inverse, so I hit the second key, sine inverse, and then I enter 2 sine 50, close parentheses, and then divide by 3. So that tells me that angle B is equal to 30.7 degrees. It's important to know, especially when you're working with the law signs, that the sine, if the sine of theta is equal to k, then the sine of 180 minus theta is equal to k. Okay. That's going back to your reference angles. You have the sine of an angle, a reference angle in quadrant 1. Then you have another angle in quadrant 2 that has that same value if you take the sine of the angle. So angle B is 30.7 degrees, but there's also another B, another angle that has that value. So I'm going to call that, well, let me just call it B1. So if I subtract 30.7 from 180, I get 149.3 degrees. So if you take the sine of 30.7, and let's do it in the calculator just to confirm it. I take the sine 30.7, hit enter, and then I take the sine of 149.3, hit enter, I get the same number. So I have an angle that could also work for this sine of b equals 2. There's two angles that are possible. I've already said that there's just one solution, right? I said that based on what we talked about in the last video, if this side, opposite angle A, the given angle, is larger than the other given side, there's always going to be one solution. So how can we verify? Well, look at the information that we have here. 149. Let's take if I say that angle B could also be 149, I say 149.3, and then I've already got an angle given that's 50 degrees. So let's add those together. Well, that gives me 199.3, and we know the sum of all three angles is going to be 180. So there's nothing left for the third angle. If two angles add up to a number larger than 180, there's no triangle possible. You don't have to do that in this particular case, because like I said, if the side opposite the given angle is larger than the other side, you're always going to have one triangle. But you can confirm that you do have one solution. So here we have just one solution. So that means in this scenario here, I got to reject this one. Can't use this one. So fill in the information. So what do we have? We have B then is 30.7 degrees. So what's angle C? Well, we found B to be 30.7. We're given A to be 50, so add those up. Add those up. It's 80.7. Subtract that from 180. And angle C is 99.3 degrees. Now what do we need? What's missing? Well, we need side C. So now we just say side C. So you can go from a side to the sine of an angle, vice versa, based on those formulas. So I take, now I know angle C, okay? So side C, little c, over the sine of 99.3 degrees should equal to any other side. Well, what do we have? I could use actually B equal 2. I could take 2 over the sine of B. I could take 3 over the sine of A, because I know both of those quantities. It's always best to use, in your calculations, to use the given data. So if you computed an angle that was missing or a side that was missing, if you can do it, use the given information. So I'm going to choose side 3 units over the sine of 50 degrees. So we want C. So basically we multiply both sides by the sine of 99.3. So C then would equal 2 3 times the sine of 99.3 degrees over the sine of 50. And that, of course, is degrees. Again, always make sure your calculator is in degree mode, otherwise you're not going to get the right solution. So now, we take the calculator, and we're going to have 3, doing the right side of this thing, 3 times the sine of 99, so this will be sine 99.3, close parentheses, and I just hit enter. I get that, and then I'm going to divide that, so hit divide by the sine of 50. Hit enter. And we hit C. Run that out to 2 places. Side C is 3.86. 3.86. So this is 3.86. Given information now was A was 3, B was 2, angle A was 50 degrees, so we're given 2 sides and the angle opposite. That's the ambiguous case. Now in this particular case, because of the information given, we have just one solution, one triangle, and here we have the missing parts of that triangle. So the problem is solved, or the triangle is solved. I don't want to make the video too long, so I think what I'll do is in a later video, I'll make the video on where you have 2 triangles and the case where you have no solution. In the method I'm giving you here, you don't really have to check out the length of the altitude and so forth. You can determine whether you have 1, 2, or no solution, possibly just by going through the steps that I'm showing you here. So we'll stop here, and thanks for watching. We'll see you next time.